Example 3, we are going to look at an application of logarithms. Before we get to that though, sometimes you may just see a logarithm written like this, the log of 100, and the base isn't written. If that base isn't written, it's really a 10. So this means the same thing. Log base 10 of 100. If you have a log written that doesn't have the base there, the base is implied as 10, it's called a common log. So again, common logarithm is a log with a base of 10. Okay, and we'll see that actually in our example here. So this is example 3. And it's kind of a lengthy word problem, so I already have that written out here. In December 2004, an earthquake of magnitude 9.3 on the Richter scale hit off the northwest coast of Sumatra, which is by Indonesia. If you know much about the Richter scale, the highest is 10, measuring the strength of earthquakes. The formula log of I1 over I2 equals M1 minus M2, so it looks kind of complicated, compares the intensity of earthquakes, where I is the intensity level determined by the seismograph, and seismograph measures seismic waves. M is the magnitude on the Richter scale. How many times more intense was that earthquake, the 9.3 magnitude earthquake, than another earthquake that was 8.7 on the Richter scale? This second earthquake, the 8.7 on the Richter scale, also hit Sumatra, and it was just a few months later. So this example here, this application, gives us a sneak into the Richter scale and magnitude. Sometimes certain values are so large, like in this case, the levels of the seismic waves that are measured are such big numbers to work with. Logs kind of make them manageable. So that's what we see here. To figure out how many times more intense this earthquake was, the first earthquake, we plug all of our values in here. Well, log of I1 over I2, are we given any of our intensities here? No, because 9.3 is the magnitude on the Richter scale, so is the 8.7. So I have to keep those as I1 and I2. The log of I1 over I2, though, equals M1 minus M2, subtracting my magnitudes. 9.3 minus 8.7. We see here, too, that we have a common log. Our base isn't written, which means our base is really 10. Okay, let's simplify a little bit here. 9.3 minus 8.7 is 0.6. And again, remember that our base is 10 here. So in order to do anything else, let's think of this in exponential form. 10 is the base for my log. 10 to the 0.6 power equals I1 divided by I2. Well, 10 to the 0.6 power, that's just a number. And it's about 3.98. Well, whatever my intensities were, my intensity for the first earthquake divided by the intensity for the second earthquake gives us 3.98. Well, that means that is our answer. Our first earthquake that measured 9.7 on the Richter scale was roughly 4 times more intense than the earthquake that was 8.7 on the Richter scale. And hopefully that kind of gives you an idea of how big of numbers we're really working with. We only have 0.6 of a difference on the Richter scale here. But we're talking it's almost 4 times more intense, the seismic waves. That's a pretty big difference.